Good evening, children. Good evening.
ma'am.
Good evening, ma'am.
Good evening. Today we are going to have the introduction to the chapter volumes and surface areas. We have not completed circles, but I thought we'll just open these two chapters simultaneously. So today we'll take the introduction to this chapter, volumes and surface areas. Part 1 you've already seen in 9th standard. So you have the same. You've seen the formula related to cubes, cuboids, cylinder, cone, hemisphere, sphere in standard 9. The addition in standard 10 is about the frustum of a cone, but this is deleted from your syllabus. Apart from what you learn in volumes and surface areas in standard 9, in 10th standard, we have the portions based on frustum of a cone, but this one has been deleted for you. So which means you're familiar with the formulae that we will, need to work out the sums in this chapter. Anyways, let's recall the formulae before we get into the questions. I'll ask you randomly. Tell me the formula to find the volume of a cone. Volume of a cone.
1 by 3 pi r
1 by 3 pi r square h.
1 by 3 pi r square h. What's the formula to find the CSA, the curved surface area of a cone? The curved
Pi RL.
Pi RL. Only the curved surface area, not including the area of the circle, not including this area. The area, the curved surface area. The curved surface area of a cone is given by the formula pi RL square units. What is the relation between L, H and R? What is the relation between L, H and R?
L square equals H square, H square plus R square.
L square is equal to H square plus R square. What's the formula to find the TSA of a cone?
Pi R into L plus R, ma'am.
Pi R into R plus L or L plus R. Square units. When it's area, it's square units. Volume, cubic units. Volume of a cone, 1 by 3 pi r square h. CSA, curved surface area, pi RL. That is curved surface area is this area. The area of, this is the curved surface area, this one, area of this portion alone. Curved surface area. The total surface area is the curved surface area and the area of the circle here. The curved surface area plus the area of this here, curved surface area pi RL plus the area of the circle pi r square is the total surface area. So pi r is common, pi r common, so we get L plus R. Pi RL plus pi r square, pi r is common, so pi r into L plus R, pi RL, pi r square. What's the formula to find the volume of a hemisphere? Volume
2
of
by 3 pi r cube, ma'am.
Volume of a hemisphere. 2 by 3 pi?
Pi r cube, ma'am.
2 by 3 pi r cubed. 2 by 3 pi. Okay, I think I should have asked you to write down. Children, write out the formula in your notebook. Give the heading volumes and surface areas. Take down the formula in your book. Please write down your notebook. Done?
Completed, ma'am.
Very good. Others?
Completed.
All right. Am I erasing the contents of the slide? Okay. So I was asking you, okay, let's do the cylinder next. The volume of a cylinder?
Pi r square h, ma'am.
Pi r square h. Cubic units. Curved surface area of a cylinder?
2 pi r h, ma'am.
2 pi r/h. Square units. Total surface area of a cylinder?
2 pi r
2
into
pi
r
H
plus h.
plus R.
2 pi r into h plus r or r plus h. So TSA is TSA is CSA plus the area of the two circles. TSA is CSA plus area of two circles. Area of two circles, one on the top and one below. So CSA is 2 pi r/h plus the two circles pi r square plus pi r square. CSA 2 pi r/h, TSA 2 pi r into r plus h or h plus r. For standard 9, you know, the formulae were explained, like how we, you know, get these formulae. So I'll share that video. So that's done in 9th standard as to how we come up with these expressions. Pi r square h, 2 pi r/h, how we come out with these expressions is explained in standard 9. So I'll just share that video with you if you're interested. If you want to know or you want to recall, you can just have a look at that video. Nothing. That video will only have the explanation to the formulae. So if you want to recall, you can just watch that video. Is it over, children?
Yes, ma'am.
Yes.
All of you? Others? Amazing, children. What's the formula to find the volume of a sphere?
4/3 pi r cube, ma'am.
4/3 pi r cubed cubic units. CSA, TSA, both are the same for a sphere.
4 pi r square, ma'am.
4 pi r squared square units. Volume of a sphere 4/3 pi r cubed. TSA of a sphere 4 pi r squared. Volume of a hemisphere
2/3 pi r cube, ma'am.
2/3 pi r cubed cubic units. Good. CSA of a hemisphere
2 pi r square, ma'am.
2 pi r squared square units. TSA of a hemisphere
3 pi r square, ma'am.
3 pi r squared. Hemisphere is the area of the circle here is pi r squared. The curved surface area is 2 pi r squared. CSA is 2 pi r squared. TSA is the CSA plus the area of the circle on the top. So 2 pi r squared plus pi r squared, 3 pi r squared. Square units. The curved surface area is 2 pi r squared. The total surface area is the curved surface area plus the area of the circle on the top. So 2 pi r squared plus pi r squared, 3 pi r squared. Square units. Done writing, children?
Yes, ma'am.
Yes.
Okay. So it's like I'm teaching only Priyadarshini and I think the other person is Thirunesh or Srinivasan. Who's that?
Srinivasan.
Srinivasan. Thirunesh, okay. The others are just relaxing. I'll be happy if all of you respond, children. It's just a tap away. Just tap on your mic and you have to speak. That's it. No great efforts to answer in the class. Just tap on the mic and speak out your mind. All right, I assume all of you finished writing. All right, see this one. Rashid got a playing top. How many of you have learned this chapter in school? Volumes and surface areas?
Ma'am, Mahatma Gandhi is
Finished, huh? Okay.
Yes, ma'am.
Completed this chapter?
Yes, ma'am.
Yes, ma'am.
Okay. Did they teach you the exercise based on frustum of a cone?
No, ma'am.
No,
No,
yeah,
ma'am.
that's deleted. I just wanted to double check. Okay. Who else have learned this chapter in school?
Amrita, ma'am.
Amrita Vidyalaya. Very good. Harshita? Then? Anybody else? Okay. Rashid got a playing top. Okay, a playing top as his birthday present. As his birthday present, which surprisingly had no color on it. So tops are mostly wooden top. Okay, mostly they're wooden. Nowadays they're available in plastic also, meaning some kind of fiber. But traditionally tops are wooden. So this is also a wooden top, I guess. Let's see. Rashid got a playing top. Okay, lattu. It's called lattu in Hindi. Rashid got a playing top as his birthday present, which surprisingly had no color on it. So probably if it was made of wood, it was just wood color. The top is in the shape of a cone. You can see the figure alongside, surmounted by a hemisphere. The entire top is 5 centimeters in height. So how is the top described, children? It is a cone. It's a cone surmounted by a hemisphere. It's a cone surmounted by a hemisphere. That is surmounted meaning on the top of a cone. On the top of the cone, there's a hemisphere. The entire top is 5 centimeters in height. And the diameter of the top is 3.5 centimeters. Find the area he has to color. So it's about area here. It's not volume, it's about area. If you have to find the volume of this solid, it will be the volume of the cone plus the volume of the hemisphere. Volume of this top will be the volume of the cone plus the volume of the hemisphere. Volume of the cone 1/3 pi r square h plus volume of hemisphere 2/3 pi r cube will give us the answer. The total volume of wood in the cone, in the top. But here it is, find the area he has to color. Now children, if say you have a brush in your hand, you have a brush, okay, a painting brush. With your painting brush, what area can you paint with your painting brush? What can you feel with a brush? Can you feel the total? Can you see the total surface area of the cone or only the curved surface area of the cone? Can you see the
only curved surface area?
Now a cone, this is a cone. See, a cone looks like this. Can you see this portion of the cone? Can you see this portion of the cone? The circular face of the cone? No, we can, that's not visible. So this area is not, so when you take the cone alone, only the curved surface area of the cone is available to be painted. The circle, since it's surmounted by the hemisphere, the circular portion of the cone is not visible. Area we have curved surface area and the area of the circle here. We have the curved surface area, which is visible in the figure in the top. And there is area of the circle here. But the area of the circle cannot, the circle cannot be painted because it's not visible. There's a hemisphere sitting on it. So what area of the cone is available to be painted is the total surface area available to be painted or only the curved surface area? If it is curved surface area, it's only this portion which can be painted. If you say the total surface area can be painted, that means you're saying you can paint the CSA and the circle on the top. And the circle on the top. Now tell me, can you paint the circle on the top?
No, ma'am.
Because it's not visible. So what area of the cone can you paint? Only the CSA. Only the CSA, because only that is visible. If you feel with your hand, you can feel only the CSA of the cone. You want to touch the top of the cone, but it's on that sits the hemisphere. You cannot see the circular portion of the cone. So only the curved surface area can be seen and you can paint only that. Now coming to the hemisphere, hemisphere. So we're talking about the area of the hemisphere. Area is the curved surface area. We have the curved surface area and we have the area of the circle on the top. This is how a hemisphere looks like. This is how a hemisphere looks like. There's a circle on the top and this curved surface area of this curved portion. Can you see the circular portion of the hemisphere? Can you see it? Only if you can see, you can paint. No, if it is not visible, that means you cannot paint that portion. Whatever you see, you can paint. Whatever is visible, you can paint. Can you see the circular portion of the hemisphere?
No, ma'am.
You cannot see it. Can you touch the circular portion of the hemisphere? Can you touch it? No. The circular portion of the cone and the circular portion of the hemisphere, they're stuck. You cannot see both of them. That means that portion is not available to be painted. So what portion of the hemisphere is available to be painted? Only the CSA. Only the CSA. The hemisphere has the circle. There is the circle. But the circle of the circular region of the hemisphere and the circular portion of the cone, they're stuck. So both the circular portion of the cone and the circular portion of the hemisphere, both of them are not visible to be painted. So what is visible is CSA of the cone and CSA of the hemisphere. So add these two. CSA of the area that is to be painted is the CSA of the cone plus the CSA of the hemisphere. Now it's very important to understand the values, that is the radius and height of the cone and the radius of the hemisphere. So let's write that first, cone, hemisphere. Before this is how you start the answer. What are the solids you see? You see two solids here, cone and hemisphere. So for the cone, you need radius and height. And if it is area, you need slant height also. You don't need this one actually. For area formula is pi RL. Okay, but we'll just write because using R and H only you can find L. Okay, so this is what you should do first. This is what you should do first. For the cone, what is the radius? What is the height? What is the slant height? For the hemisphere, what is the radius? That's enough. For a hemisphere, you need only R. If you have R, you can answer any question. Now, children, tell me, what is the radius of the cone?
3.5 by 2.
3.5 by 2.
3.5 by 2 or? .75 centimeters. What about the height of the cone?
5 centimeters.
Who's that?
Ma'am, 1.5 centimeter, ma'am. Height of the cone is 1.5 centimeter.
1.5
centimeter.
5. No, somebody said 5. Who's that? Who said 5? Thirunesh. Okay, good. Thirunesh says 5. All right. Thirunesh, is the height of the cone 5 centimeters, Thirunesh? Please observe the figure. The height of the top is different from the height of the cone. The height of the top, okay, class, listen carefully. The cone and the hemisphere put together is the top. When we say height of the top, it is the height of the cone plus the height of the hemisphere. Height of the hemisphere. The height of the top is a full thing. The height of the top is the height of the cone. See, the height of the hemisphere plus the height of the cone is the height of the top. The hemispherical height plus the conical height is the height of the top, because top is cone and hemisphere put together. When we say cone, it's only the cone. When we say hemisphere, it's only the hemisphere. But when we say top, it is the cone and hemisphere together. So this 5 centimeters is the total height of the top, which includes the height of the hemisphere and the height of the cone. What is the height of the hemisphere? What is the height of the hemisphere? The height of the hemisphere is equal to its radius. The height of the hemisphere is equal to its radius. Let me draw it more neatly. The height of a hemisphere is equal to its radius. See, hemisphere, radius. The height is also equal to the radius. The height of a hemisphere or a hemispherical bowl is equal to its radius. Whatever is the radius is the height of the hemisphere. What is the radius of the hemisphere? What is the radius of the hemisphere?
1.75.
1.75 centimeters. So what will be its height? Same thing. But why we don't write the height of the hemisphere? Because we don't need it in the formula. We don't write. You can mention nothing wrong. Height of the hemisphere is 1. You can call it H1. We don't need it in the formula, but height is also the same thing. 1.75 centimeters. Now the total height 5 minus the hemispherical height will give you the conical height, correct? 5 centimeters minus the total height minus the height of the hemisphere. The total height minus the height of the hemisphere will be the conical height. So the total height, which is the total height of 5 centimeters minus the conical minus the hemispherical height 1.75 is the conical height 3.25 centimeters.
3.25 is height. Correct.
Children, it's very easy. You all understand it clearly, right? So we need to be very careful. The entire top is 5 centimeters high. It's not the height of the conical portion. It's the height of the top. Now using the values of R and H, we should find slant height, because slant height is what we need to find area. Area pi r L. We need the value of L. So L is equal to root of H square plus R square. You should work this, and you know the value of R and H. You should fill that and get the value of L. So once you read the question, if the figure is not given, you should draw the figure. Follow this order. Follow this order. Read the question. Identify the solids involved. Mostly it will be a combination of solids for you. The figure will be a combination of 2 or more solids. So read the question, draw the figure. Mark the values given in the figure. After please write out the solids involved in the figure. The solids here are cone in the top. The figure is about a top, and the solids involved are cone and hemisphere. And for a cone, what do you need? Radius, height, slant height. What do you need for a hemisphere? Radius. So read the question and get these values first. Don't start working pi RL plus, 2 pi r square. Don't start working this. What are the, by mistake, if you take the height of the cone as 5, height of the cone as 5, everything is correct, but this value you've taken incorrectly. All your efforts will go waste. The values are very, very important. From the question, you must get the values of, the radius, height, slant height, whatever involved correctly. Only then your final answer will be correct. Now, this is the second thing. So read the question, draw the figure. After that, give the headings of the solids involved in the figure. And from the question, get their values, radius, height, and other. Get their values from the question. And now the area that is to be painted is the CSA pi r l, CSA of the cone plus the CSA of the hemisphere, 2 pi r square. Show you the answer. Please start working. As you work, understand what you're writing and get your doubts clarified. Any doubt anywhere, please ask me, children. So I normally don't substitute the value of pi. Okay, so I normally calculated in pi, so like 12.6 pi, and once for all use the value of pi, 22/7. Don't use 22/7 everywhere. Don't substitute the value of pi. Get the answer in pi, 12.6 pi. Get the answer in pi, and then substitute the value of pi, 12.6 into 22/7. So children, here you should know how to find the square root by long division method. You should know how to find the square root of 13.625 by the long division method. For this also, I'll share a video. Have a look at the video. How to find the square root of a number. So now I got 3.69. Just rounded it to 3.7. Now that is your choice again. You can have it as 3.69 also. You can have it as 3.69 also. I've rounded it off to 3.7. So that also is like your choice. So you can have it as 3.69 or round it to 3.7. Am I audible and clear, children?
Yes.
Yes, ma'am.
Thank you. Thank you. So see, finished writing, children?
1 minute.
Yeah.
Completed.
All right. So let's revise the answer. So see here, as I told you, you should first write out the solids, hemisphere, cone, radius of the hemisphere. The height of the hemisphere is equal to the radius, 1.75 centimeters. Cone radius is this one. Height of the cone is the total height minus the height of the hemisphere. Then to calculate L, for the cone you need to calculate L. So L is equal to root of h square plus r square, and all this you'll have to find the square root by long division method. And here substitute the values, don't use the value of pi. So add this and get the answer in pi, and once for all use 22/7. So I think the learning in this answer is that we should be careful while we calculate the height of the cone. If it is given height of the cone, it is the height of the cone, but it's given height of the entire top. The height of the entire top. Height of the entire top meaning it is two heights together. The height of the entire top is the height of the hemisphere plus the height of the cone. Hemispherical height plus conical height is equal to the height of the top. So be careful there. Next one. The decorative block shown in the figure is made of two solids, a cube You can see the cube at the bottom and a hemisphere on the top. The base of the block is a cube with edge 5 centimeters, and the hemisphere fixed on the top has a diameter of 4.2 meters. Find the total surface area of the block. So this block can be lifted, children. It's not fixed to the ground. The block is not fixed to the ground. You can lift this decorative block because it's not given that it's stuck to the ground or something. So you can lift this decorative block. So how many faces of the cube can you see completely? Please understand how the block is. The block is the decorative block is a cube surmounted by a hemisphere. It's a cube surmounted by a hemisphere. My question is, how many faces of the cube can you see completely, fully?
5.
Yes, 5 faces. Without any disturbance, 5 faces of the cube are visible completely. What's happening on the 6th face? On the 6th face, that is the face on the top, sits a hemisphere. So the 6th face, okay, a cube is made of 6 square faces. Completely visible. The 6th square face, the area of the 6th face, is not completely there. Some part of it is there because why? Because on the 6th face, just imagine this is the 6th face. Okay, this is that face on the top. This is that face on the top. Okay, now this edge is actually 5 centimeters, but the diameter of the hemisphere is only 4.2. It's less than 5. So it's like this is only 4.2. The diameter is only 4.2. So there in the sides also there is little portion left, and the portion here. In this figure, if I have to show you in this figure, see this full thing is 5. This full thing is 5 centimeters, but there's only 4.2. So that 0.8, so 0.4 here in the side and 0.4 here in the side. And then all this area. Because even if the circle completely occupies, see, even if you draw a circle, if you inscribe a circle, even then some portion of the square will be visible. Even if the square touches all the sides, even if the circle touches all the sides of the, the square face, this portion of this area is still there. Not occupied by the circle. Now, it's how I would explain, the total surface area. When you have the block in your hand, you feel the entire solid with your hand. That is, you rub your hand over the entire solid. What are the portions that you can feel with your hand? All that is area. So convert all that to a formula. So when you feel the solid with your hand, you can feel 5 faces of the cube completely. You can see that the 5 square faces of the cube are intact. They're all there completely. So the area of those 5 faces is 5a squared. 5a squared. There is this area. Then talking about the 6th face. The area of the 6th face is a square. Let's do it slowly, okay? This is the area of the 6th face, a square. See, the area of 5 faces is 5a squared. That's all there. We are talking about the area. Find the total surface area of the block. The total area of the block is equal to. Area means all that portion which can be painted. So you can paint the area of the 5 faces of the cube. Each face is a square, so 5 faces, 5a square. Then sixth face, you're adding a square for the sixth face, but no, this area is not available completely. So what portion is not available? Since the hemisphere sits on the square, the circular base of the hemisphere is missing on, see the circular base of the hemisphere occupies some space on the top. So a square is not completely there. A square minus pi r square is the area available on the sixth face. A square minus pi r square. Well, how did we get pi r square? Because what portion of the hemisphere sits on the sixth face? The circular portion. The circular portion of the hemisphere sits on the sixth face. So when a circle sits on the sixth face, that circular portion is not available. So the total area on the top is a square minus pi r square. This is the remaining area. This is the remaining area, the area of this portion. The area of this portion. Okay, the area of this portion is the total area a square, because the area of the sixth face is a square, minus when a hemisphere is inverted like this on the square, this portion sits on the sixth face of the cube. So this one is not, this area is taken up. This area is taken up on this face. So the total area a square minus pi r square. Only this area is available on the sixth face. Now I would divide this into 3 portions. So now if you have to paint up this block, you will paint the 5 faces, the 5 square faces. Then on the sixth face, only this area will be remaining to be painted. A square minus pi r square. So that is, you will paint this one. This is only a square minus pi r square. All around the hemisphere. Around the hemisphere is a square minus pi r square. But supposing you paint the 5 faces, 5a square, and on the sixth face you paint up this area. Do you think the block is entirely painted? If you paint the 5 faces of the cube, and on the sixth face, the remaining a square minus pi r square. If you paint up this, do you think the block is entirely painted? If not, which area is still not painted?
The CSA of the sphere.
The curved surface area of the hemisphere. Just imagine you're painting this block red. 5a square is painted red. And on the sixth face, the remaining area. On the sixth face, the remaining area, a square minus pi r square. That's also painted. This is painted red. This is painted. All this is painted red. See? All this is painted red. Now there is something still not painted red. This is only 5a square. This is 5a square. It's painted red. And this is only a square minus pi r square. That's also painted red. Now this portion is not still painted red. That is the CSA of the hemisphere. The CSA of the hemisphere. So plus the CSA of the hemisphere, 2 pi r square. So break down the area into 3 portions. Break down the area into 3 portions. The area, the TSA of the block, you should not do this, children. What you should not do, what you should not do is, you should not write it as TSA of hemisphere. This is incorrect. If they ask you to find the volume of the block, are you all listening? I'm scared you've already learned it in school. I'm not. I hope all of you are listening carefully.
Yes, ma'am.
Children?
Yes, ma'am.
Just because it's over in school, start working the answer. When you're asked to find the volume of the block, it's the volume of the cube plus the volume of the hemisphere. That's correct. Volume of the cube, a cube. Volume of the cube, a cube. or edge cube, whatever you call it, plus the volume of the hemisphere, 2 by 3 pi r cube. This is correct. The total volume of the block is the volume of the cube plus the volume of the hemisphere. Volume works like that. Area does not work like that. Areas, whatever areas available only you can add. You cannot take the total surface area of the cube and the total surface area of the hemisphere. Some portion of the hemisphere is not visible. Just because they're asking you to find the TSA of the entire block, you cannot say TSA of the entire block is TSA of cube plus TSA of hemisphere. That's wrong. Because some part or some area of the cube is not visible and some area of the hemisphere is not visible. So you cannot do this. Whenever it is area, just take it like this. Whatever is visible and can be painted, only that you should account. For area, you should account only those portions which are visible and which can be painted. Volume, if there are two solids, write the formula. Now here, volume of cube plus volume of hemisphere finishes the volume of the block. But area does not work like that. Area is whatever portion is available, whatever portion is visible, whatever portion can be painted. Only that should be accounted. So we should do it part by part. So as we started, the area available is equal to all the five faces of, not all the five, sorry, 5 faces of the cube are completely visible. 5a square, 5a square, this area. Because one face is a square, 5 faces 5a square. So 5a square you can completely paint. Now coming to the 6th face. Okay, 6th face. You want to paint a square, but a square is not there. Some part of a square is not there. Which part of a square is not there? Pi r square. Why? Because when you invert the hemisphere, that circle sits on the square. So that circular portion is taken away. So in a square, this area is not available. This area is not available. On the top face a square, pi r square is not available. So this is the area remaining on the 6th face. This is the area remaining on the 6th face. So that means we have painted this one. This is only a square minus pi r square. This is a square minus pi r square. And this one is 5a square. This is 5a square. Now we feel we are done. But no, we are not, because we have not still painted up this one. We have not still painted up this one. What is this? That's nothing but 2 pi r square, the curved surface area of the hemisphere. So children, imagine if you have to paint this block, you will paint the 5 faces of the cube, 5a square. On the 6th face, you will paint a square minus pi r square. And apart from that, you will also have to paint the CSA of the hemisphere. So this expression is the total area or the total surface area of the block. You can simplify this. So it's 5a square plus a square minus pi r square. 6a square plus pi r square. 6a square plus pi r square. Is this right? On simplifying, 6a square plus pi r square. Now, with the value of a is 5 centimeters and the value of r, diameter is 4.2, so radius is 2.1. So substitute the values in this expression to find the total surface area of the block. Okay, so here I've just done it in a different way. I've taken all the 6 faces, area of all the 6 faces and removed. I've taken the area of all the 6 faces. It's the same, children. I've taken the area of all the 6 faces, but on the 6th face, pi r square is not there. So I've subtracted that. I've taken the area of all the 6 faces, but on the 6th face, pi r square area is not there, so minus pi r square. Plus the CSA of the cone, which is 2 pi r square. So 6a square plus pi r square, same thing. I've accounted all the 6 faces, 6a square, but then you realize, oh no, 6a square on the 6th face, pi r square area is not there. So you subtract pi r square. And then you add the CSA of the hemisphere. Please write down. If you like the earlier one, I can just write it here for you. The earlier one, you can write this TSA of the block is equal to area of 5 faces of the cube plus area of the top face minus area of circle plus CSA of hemisphere. The TSA of the block is the area of the 5 face of the cube plus the area of the top face minus area of the circle plus CSA of hemisphere. So this is 5a square plus a square minus pi r square plus 2 pi r square. So this is 6a square. Please write this. Start with cube, edge 5 centimeters, hemisphere, radius 2.1 centimeters. Write that. You can take down this. Do we understand the expression to find the total surface area of the block, children?
Yes, ma'am.
Okay,
Yes,
Shanti.
ma'am.
All right. So read the question right. The two solids here are cube and hemisphere. For hemisphere, you need radius, write that. For cube, you only need the edge of the cube. So write that. Then TSA of the block, you must have written the earlier one. TSA of the block, so you get 6a square plus pi r square, substitute the values. And this is the TSA of the block. Is it over, children? Finished writing?
Yes.
Okay, the next one. A wooden toy rocket. A wooden toy rocket is in the shape of a cone. Is in the shape of a cone, and that cone is mounted on a cylinder. That cone is sitting on a cylinder. That's mounted. That means that is placed on a cylinder. The cone is placed on the cylinder. A wooden toy rocket is in the shape of a cone mounted on a. This cone is placed on a cylinder, as shown in the figure. The height of the entire rocket, see that the height of the entire rocket is the cone and the cylinder together. See, they've described the rocket. How do we know? They've described the rocket. What is this wooden rocket? It is in the shape of a cone mounted on a hemisphere. So the cylinder and cone together is a rocket. Cone is cone, cylinder is cylinder, rocket is cone and cylinder. The height of the entire rocket is 26 centimeters. That means the height of the cone and the height of the cylinder together is 26 centimeters. The height of the cone plus the height of the cylinder is 26 centimeters. The height of the entire rocket is 26 centimeters, while the height of the conical part is 6 centimeters. So that means the height of the cylindrical part, conical part is 6, totally 26. So cylindrical part will be 26 minus 6, 20 centimeters. The base of the conical portion has a diameter of 5 centimeters. I'm pausing so that you can, absorb that information. The base of the conical portion has a diameter of 5 centimeters, while the base diameter of the cylindrical portion is 3. That means the cone will stick out of the cylinder. On the top here, the circular portion of the cylinder does not coincide with the circular portion of the cone. The circular portion of the cylinder does not coincide with the circular portion of the cone. Because the diameter of the conical part is 5 centimeters, but the diameter of the cylindrical part is only 3 centimeters. This one is 3. See here on the top. On the top here, the cylindrical portion, this is the circular top, cylindrical portion. But the conical portion will be bigger because the diameter is 5. So they don't coincide. The cone has a circular portion like this. Cylinder also has a circular portion on the top. But the two circular portions will not coincide. The circular portion of the cone will stick outside. It will stick outside the circular portion of the cylinder. That means if you look under this portion, you can see a ring. You can see a ring. You can see a ring. That's what is shown here. So under this, if you look under this, you can see a ring. because you can see two circles. You can see one big circle and one small circle. That circle you cannot see, but there'll be a big circle, radius 5, and this is the top of the cylinder, radius 3. So you can see this portion sticking out. You can see that this portion is sticking out. This is the circular portion of the cone. This is the circular portion of the cylinder. So this portion will be sticking out. This portion will be sticking. You can see this portion under, here, you can see this portion. Imagine that. So, okay, reading further. If the conical portion is to be painted orange and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. So you should find the area of the, so the conical portion is painted orange, cylindrical portion yellow. Okay, so conical is orange, cylindrical is yellow. So you should find the area of the cylindrical portion, which is painted yellow, and the area of the conical portion that's painted orange separately. Now, the three things we see here are, cylinder, cone, ring. Cylinder, cone, and ring. What is the radius of the cylinder, children? What is the radius of the cylinder?
3 centimeter.
3 by 2.
3 by 2. 3 by 2.
1.5 centimeter.
1.5 centimeters. Okay. What's the height of the cylinder?
20 centimeters.
20, ma'am.
20 centimeters. So
20
for,
centimeters.
yeah. So the three things which the ring is not a solid. Ring is a plane figure. The two solids are cylinder and cone. Ring is a plane figure. Now for the cylinder, the radius is 1.5 centimeters and the height is 20 centimeters. What about the cone? What's the radius of the cone?
2.5 centimeter.
5 by 2, 2.5 centimeters, because its diameter is 5. And what's the height of the cone?
6 centimeter.
6 centimeters. For area, we need to find the slant height of the cone, because pi r L, no? So we need to find the slant height of the cone. So we find L. And then for the ring, what's the internal radius?
Three centimeters.
Internal radius.
Can you repeat, ma'am?
What is the internal? What is the radius? Now the ring has two circles, two concentric circles. What is the radius of the inner circle? And what's the radius of the outer circle of the ring?
Inner circle, it is 1.5 centimeter.
An outer circle?
2.5.
2.5 centimeters. That is, the radius of the cylinder will be the inner radius. The radius of the cone will be the outer radius. Having got all these values, we'll have to find the area that is to be painted orange and yellow. So all the conical portion. In the conical portion, how much can be painted in the conical portion? How much can be painted in the conical portion? Conical portion, is a CSA completely there to be painted?
Ma'am.
Is a CSA for the conical portion, is a CSA completely available?
Yes, ma'am.
Yes, ma'am.
So pi r plus, is the base of the cone fully available to be painted?
No, ma'am.
No, ma'am.
No. What portion is sticking out? This portion is sticking out, right? This portion is only sticking out. Under this cone, you can see something like this. What is the area of this portion? Area of the outer circle minus the area of the inner circle. Pi capital R square minus pi small r square. So we say the area of the ring is, see here, this is the area of the outer circle. Area of the outer circle minus the area of the inner circle. Pi common. This is the area of a ring. This is the area of a ring. Area of the outer circle minus the area of the inner circle. And this ring is a part of the cone, not cylinder. So the area of the cone or the area of the conical portion that is to be painted orange is equal to CSA of the cone pi RL plus area of a ring pi R square minus R square. For the cone or in the cone, there are two portions visible. One is the CSA of the cone that's completely there. And if you look under the cone, you don't see the circular portion of the cone fully. You only see a ring. So area, the CSA of the cone plus the area of a ring. The ring is pi R square minus R square. Now tell me what portion of the cylinder can you see? Can you see the CSA of the cylinder? Can you
Yes,
see
ma'am.
the CSA of the cylinder?
Yes, ma'am.
Can you, yeah, can you see the area of the circle on the top of the cylinder?
No, ma'am.
A cylinder has two circular, portions. A cylinder has two circular portions, one on the top and one at the bottom. Is a circle on the top seen in the cylinder?
No, ma'am.
What about the circle at the bottom?
Yes, ma'am.
So in the cylinder, the CSA is completely visible. So pi r 2 pi RH plus the area of the top. No, it's not visible. Leave it. Plus the area of the bottom, that is the circle below. Yes, pi plus.
Yes, pi R square.
Correct. So for the cone, what is visible for the cone? For the cone, the CSA is visible and the area of the ring is visible. But for the cylinder, CSA, that is 2 pi RH is visible, plus the area of the base, pi R square, and top is not there completely. Completely the top is not there. Because the circular portion of the cone sits on the top of the cylinder. It hides the top of the cylinder completely. The base of the cone covers the top of the cylinder completely. That cannot be painted. The top of the cylinder, you should break it to paint it. You cannot see the top circle of the cylinder in the rocket. What you can see 2 pi RH, that is the CSA. And you can also see the area of the base pi R square. Area of the top you cannot see. CSA plus area of the base plus area of top is the total surface area. Top area is not visible. That's all it is. So you should write out cone, cylinder, ring separately, write out the values, and then analyze the cone and cylinder separately. and hence find the area to be painted orange and yellow. Important question. Please write slowly. Read first. Read the slide. Read the content of the slide. Understand and then copy. I'll just get back, children. Please work this. Finish writing, children. Finish writing, children.
Ma'am.
Okay. So see, what do you see here? For the cylinder. For the cylinder, we need to write the radius and height. Radius and height. For the cone, also radius and height. I've just used, that is, see, for both the cylinder and cone, we need radius and height, right? So where the value is small, I've used small r. Where the value is large, I've used capital R. For H also, I've used a capital H where the height is more. I've used a small h where the height is less. Or you can use R1, R2, H1, H2. You need to differentiate. You cannot say R for both. The formula also should be modified. Either say R1, R2, H1, H2, or you can use a capital letter and a small letter based on the values. So what I have done is radius is 1.5 and 2.5. So I've used a capital R here and a small r here. Height is 20 centimeters, 6 centimeters. So small h here, capital H here. Okay, so for cylinder, we need radius and height. For cone, we need radius and height. And since it's area, we need slant height. We need slant height. Root of h square plus r square. This is exactly 6.5. Exactly 6.5 centimeters. And then for the ring, inner radius, outer radius. This is the inner radius, this is the outer radius. The radius of the cone is outer radius. Cylinder is inner radius. The smaller one is cylinder. The smaller circle is cylinder circle. The bigger circle is the cone circle. Is this part understood, children? Please, any doubts here?
No, ma'am.
Okay. One person is representing the whole class. Class, any doubts?
No, ma'am.
No, ma'am.
Okay. Same voices. Thank you, Priyadashini, Shiva, Srinivasan, and Shakti now. All right. So once you have these values clearly, now we'll find the area to be painted orange and yellow. Orange is cone. So in the cone, what is visible? You can paint the CSA of the cone and the ring which you see, this ring which you see. So this is the area of the, this is the curved surface area of the cone, and this is the area of the ring. Curved surface area of the cone, area of the ring. Substitute, and yellow is the cylinder. So cylinder, you can see the CSA of the cylinder and the area of the bottom of the cylinder. Top you cannot see. You can see the CSA of the cylinder completely. You can see the area of the bottom of the cylinder. Top circle you cannot see because the cone is sitting on it. So 2 pi RH, but write the letter correctly. 2 pi RH. H is this H for the cylinder. 2 pi RH plus pi r square. Again, in pi r square, which pi r square? Not pi capital R square. Area of the bottom of the cylinder. This one. This is smaller. This is smaller. This one. This is the radius of the cylinder, which is smaller. So plus pi r square plus pi small r square. So you should ask me if you want it to be more clear. Please ask your questions. All right. This is homework. Take a screenshot. Take a screenshot in this homework. Two cubes, each of volume 64 centimeter cubed, are joined end to end. Find the surface area of the resulting solid. This one also I'm not explaining. Please have a look at the answer and write it down. Understand and write it down. Yeah, this is the next one. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. Mounted by a hollow cylinder. That means a hollow cylinder sits on a hollow hemisphere. Hollow, a vessel. See, the vessel is the hemisphere and cylinder put together. A vessel is in the form of a hollow hemisphere mounted by the hemisphere is mounted by a hollow cylinder. So bottom is the hemisphere, on top is a cylinder. The diameter of the, okay, let me draw that. This is the hemispherical part of the vessel and this is the cylindrical part. This is the cylindrical part. The diameter of the hemisphere is 14 centimeters. The diameter of the hemisphere is 14 centimeters. And the total height of the vessel is 13 centimeters. The total height of the vessel. So the vessel cannot be like this. One minute. Yeah, children. So the diameter is 14, so the radius is 7. Radius is 7. And the total height of the vessel is 13 centimeters. Find the inner surface area of the vessel. Find the inner surface area of the vessel. What are the two solids here?
Cylinder and hemisphere.
Cylinder and hemisphere. Very good. Cylinder and hemisphere. What's the radius of the cylinder?
Seven centimeter.
7 centimeter.
7 centimeters. What about the radius of the hemisphere?
7 centimeter only.
Yeah. What's the height of the cylinder?
6
6
centimeter.
centimeter.
13 minus 7, 6 centimeters. Because the total height 13 minus the hemispherical height 7 will give the cylindrical height. Total height 13 minus hemispherical height 7 is equal to the cylinder's height 6. Now we have to find the inner surface area of the vessel. Any doubts with the values?
No, ma'am.
No, ma'am.
All right. So what is the expression to find the inner surface area of the vessel? What is the expression that is to be used to find the inner surface area of the vessel?
CSA of the cylinder and the cone.
Correct. Inside, what can you see? You can see the hemisphere CSA. Inside the vessel, you can see the hemisphere CSA and the cylinders CSA. Because for a hemisphere, only if the circular portion is also accounted, it will be TSA. And for a cylinder, only when the circle here and circle here both are taken, it is TSA. So without this circle for hemisphere, it is CSA. Without these two, for the cylinder, it is CSA. The inner surface area of the vessel is the CSA of the hemisphere plus the CSA. We're saying CSA because the circular portions are not there. You can see circular, you can get the feeling of this circle, but there is no circle to paint. Yes, please mark this answer, children. Done?
One minute, ma'am.
Okay. Don't get, like Worried about H and H1, that's your choice. In two places we have height. So you should differentiate. You can say small h, capital H, or H1 and H2, or H and H1. Is it over, children?
Yes, ma'am.
Okay, so you can see, the hemisphere has a circular portion, but that's not there to be painted. The cylinder also has two circular portions, but where are the circular portions in this vessel? You can see the brim, but you cannot see the circles. So it's only the CSA of the hemisphere plus the CSA of the cylinder. I think if we take up this, it will take time. Okay, we'll just see the values and stop. We'll continue this one tomorrow. A toy is in the form of a cone of radius 3.5 centimeters mounted on a hemisphere of the same radius. The cone is mounted on a hemisphere. The cone is mounted on a hemisphere. A toy is in the form of a cone of radius 3.5 centimeters mounted on a hemisphere of the same radius. The total height of the toy is 15.5 centimeters. The total height of the toy is 15.5 centimeters. Find the total surface area of the toy. See, you should not, get deceived by the word total surface area. Total surface area does not mean you should use all total surface area formula. No, total surface area is all the area that is available on the toy. Again, that area which can be painted. So now, what are the two solids here? Name the two solids.
Cone and
Cone and
hemisphere.
hemisphere.
Cone and hemisphere. Now for the cone, what values you need?
Can you repeat, ma'am?
Radius and slant height.
Yeah, for the cone, what values you need for the cone?
Slant height and radius.
Slant height and radius.
What's the radius of the cone?
3.5.
3.5. What is the height, the perpendicular height of the cone?
12 centimeters.
12, ma'am. 12 centimeter.
Okay, 1 minute, children. What's the height of the hemisphere?
3.5 centimeter.
3.5 centimeters, the height of the hemisphere. What's the total height?
15.5.
So 50. What is the total height made up of?
Height of the cone and the radius of the hemisphere.
No, you should not say radius. You should say height of the hemisphere. The total height is the height of the cone and the height of the hemisphere, correct?
Yes.
Yes.
Yes, ma'am.
Yeah. So from the total height 15.5, if you take away the hemispherical height 3.5, you will get the conical height 12 centimeters. And then you should find the slant height. For the cone, you should find the slant height. So like this, you should get the values for the cone and the hemisphere. For cone, radius is 3.5, height is 12, and slant height you'll have to work. For the hemisphere, radius is 3.5. So keep all this ready. And now write the TSA formula. What's the meaning? What's the expression to find the TSA? Tell me. What is available? Feel the toy with your hand. Where whatever area you can feel, all that you should take into account. For the cone, is it TS? Is it pi r into r plus L or pi r L?
Pi r.
Pi r.
Pi r L, because ask yourself, can I see the circle of the cone? Can I see the circular portion of the cone? No, you cannot see it. So that means no total surface area, only curved surface area. For the hemisphere also, can you see the circular? For the hemisphere has a circular top. Can you see the circle on top of the hemisphere? You cannot see. They're stuck. The two circles are stuck. You can only see the curved surface area of the hemisphere. So pi RL plus
2 pi r square.
2 pi r square. I'll let you take a screenshot and complete this. Take a picture. Take a picture, children. Complete this. All right, class, use the emoji. Raise your hand. Only 12 students. Shivani, Priyadarshini, Thirunesh, Sudarshan, Srinivasan, Shriya, Lakshita, Manasa, Muttuvel, Shakti, Bala, Harish, and Akshay-Ram. All right, children. Very good. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you.
Thank you.
Thank you. Good night, children.